In this video, I lay out a 10-step roadmap that you can follow to go from a beginner to a robotics software engineer completely online and mostly for free. Hi everyone, my name is Dr. Robot. I have a PhD in surgical robotics, and this roadmap is based on my 6+ years of experience working in the robotics industry. Alright, before we start, I'd like to encourage you to watch the video to the end. Why? You'll find out. Alright, let's go. Step 1, learn math. When it comes to math, you need to learn calculus, linear algebra, and statistics. But is math really used in robotics? And if so, where? Calculus is used to develop algorithms such as navigation and mapping for robots. Matrix and vector algebra is used in AI, computer vision, and robot kinematics. Statistics is used in computer vision and machine learning. As always, refer to the description box for online courses, books, and all other resources discussed in this video. Step 2, learn programming languages. There are 3 programming languages that you need to know as a robotics software engineer. The first programming language to learn is C. But why C? Because a lot of hardware libraries used in robotics use C. These libraries allow interaction with low-level hardware and real-time performance. Additionally, C is one of the most efficient programming languages available. Here's an online course that I selected for you that is free and highly rated. Also, this is a book that you can read to learn C, but just read chapter 1 to chapter 4 for now. Alright, the second programming language to learn is Python. But why Python? Because Python has a lot of libraries that allow you to prototype robotic algorithms concepts, visual data, and run tests rapidly with less coding compared to C or C++. Python is also the preferred language to program a Raspberry Pi and can be also used with ROS. Python is the programming language for artificial intelligence or AI. Here's a Python course that will teach you just the basic. I'll recommend you just take this course for now, and depending on your project needs, learn more advanced topics and libraries in the future when and if needed.
You do not have to have a bunch of math. I do not expect math. I do not expect that you've taken any other programming classes. I don't expect you to know anything about computers. I think no matter what your background is, you can program. That's why it's called programming for everybody.
Okay, the third programming language to learn is C++. C++ is a must-learn programming language if you want to build a career in the robotics industry. But why C++? Main reasons are performance, memory management, scalability, and being object-oriented. Note that you can use Python or C++ with ROS. I'd like to mention that there are always questions on C++, even advanced topics such as inheritance, C++ design patterns, in job interviews for a robotics software engineering role. So learn these concepts very well. Step 3, learn Linux. As a robotics software engineer, you need to know Linux. But why? Because Linux is the preferred OS for majority of robotics projects, mainly because it's open source, it's secure, stable, and customizable. Besides, ROS and Gazebo both run on Unix-based platforms, so if you ever need to use ROS or Gazebo, you will need to know Linux. Here's an online course that I personally took to learn Linux, which is a very good course and it's free. But do you need to learn ROS? I suggest you do not learn ROS for now and only learn it if and when you end up using it in a project. Step 4, smash the subscribe button if you don't want to miss the next video, which is an interview with a robotics software engineer who works for iRobot, the company who makes Roomba vacuum robot. The real step 4, learn algorithm and data structure. Algorithm and data structures are 2 of the most essential courses to take for anyone who wants to become a programmer. Besides, there are always, and I say it with high confidence, at least 3 to 4 questions on algorithm and data structures in job interviews for robotics software engineering roles. But what will you learn in these courses? Check out the About page for the 2 online courses I have picked for you. Step 5, learn Mechatronics. Mechatronics is a must-learn skill for anyone who wants to become a robotics engineer. But what is Mechatronics? check out step 6 of this video to learn more. Here is probably the best online course to learn mechatronics. During this course, you will build and program a robot. Additionally, I highly recommend you buy an Arduino or a Raspberry Pi and do some hands-on projects at home.
Arduino is an open source electronics platform with tremendous potential. It's a small computer-like object that brings the physical and the digital worlds together. Arduino was introduced as a tool for students who had no experience in electronics programming.
Speaking of electronics, this video is sponsored by JLC PCB. JLC PCB has been a professional PCB supplier since 2006. Let me show you how you can easily place an order for your PCB for as low as $2. Just head over to jlcpcb.com, then click order now, then select add your Gerber file, browse and select your Gerber file. Once it's processed, it automatically detects your board size, number of layers, and other information. Once you're happy with everything, just click Save to Cart. Once it's added, you can view your board one more time and then simply check out just like you would do on any other e-commerce website. Step 6, learn robot vision. Robot vision is used in mobile robots, humanoid robots, self-driving cars, drones, surgical robots, and many more. Robot vision is a broad term that includes image processing, computer vision, and machine learning/deep learning. Here is a simple example for you to understand how these three concepts are used in practice. Let's say you want your robot to track a tennis ball. You first use image processing techniques to convert a color image of the object to grayscale. Next, you use computer vision techniques to detect the object within that image. After that, you use machine learning/deep learning techniques for pattern recognition and decide if the detected object is a tennis ball. And then if it is a tennis ball, you just track it. You remember I said linear algebra is used in computer vision?
Yep.
The reason is images are basically 3D matrices and you do a lot of matrix operation in computer vision. OpenCV is the most popular computer vision library that you can use with or without ROS using both Python and C++. Okay, so here's a comprehensive online course that will teach you all three concepts. Please note that this course will teach you machine learning, but machine learning is not the focus of the course. Artificial intelligence, which encompasses machine learning and deep learning, is a huge field on its own that has applications in robotics and many other fields. Besides, many of the existing robots, such as Boston Dynamics robots, are not full AI robots yet. So my recommendation is to not get into AI at this point, unless you want to become a self-driving car engineer, which in that case, you can enroll in and complete this Nano-degree program offered by Udacity.
Hey, what happened?
Step 7, learn localization, path planning, and navigation. Simultaneous localization and mapping, also known as SLAM, is a method in robotics mainly used for self-driving cars, robot vacuums, robot dogs, and other mobile robots. SLAM lets you build a map of an unknown environment and localize your robot in the map at the same time. Have you ever wondered how a robot vacuum works? Robot vacuums with SLAM use data from the wheels and cameras and other sensors to determine the amount of movement needed. This is called localization. The robots also simultaneously create a map of the surrounding environment and obstacles. This is called mapping. Our guest from iRobot will talk more about SLAM and how robot vacuums work in the next video. So stay tuned and subscribe. Now, if you're interested in specializing in SLAM, here's a great Nano-degree program offered by Udacity that you can enroll in and complete. Step 8, robot kinematics. As a robotics software engineer, you may need to implement forward kinematics or inverse kinematics for a robot arm. Additionally, you will have to deal with coordinate system transformations during your career as a robotics software engineer. And that's why you need to learn robot kinematics. If you want to know what robot kinematics is, please check out step 7 of this video. In summary, there are three concepts that you need to learn: coordinate system transformation, forward kinematics, and inverse kinematics. All right, now remember I said watch this video to the end. The reason is right here, I'm offering a 6 months of free mentorship to one lucky viewer each week for 3 months, and maybe beyond, who knows. Just email me with the subject Robotics Software Engineer and you will receive an email from me if you are selected in that week. Step 9, learn control system design. As a robotics software engineer, you don't need to be an expert in control system design. Usually robotics mechanical engineers or robotics electrical engineers are responsible for developing the control system in a robotics project. As a robotics software engineer, however, you only need to know what a PID controller is and how to implement it. And that's why the course I selected for you focuses on PID controller. Now, do you want to know what control system design is?
Nope.
Check out the last step of the 8-step roadmap to becoming a robotics mechanical engineer video. The link will be down in the description section. Step 10, learn software development processes. This is the last step of this roadmap and one of the most practical steps that will prepare you for your job interviews and even your first job as a robotics software engineer. Here is a great course I selected for you. In this course, you will learn processes that are used in the industry to develop software products. This course covers requirement definition, software architecture, software version control using Git, software testing, and software agile development. Take this great course and you'll thank me later. All right, we covered all 10 steps. Let me know if you have any questions in the comment section, especially if you're a beginner. I'll make another video defining some hands-on projects to exercise some of the skills discussed in this video. So please consider subscribing to not miss that video. Thank you very much, and I'll see you in the next video.